Hello, everyone. Welcome to ISART. My name is Dr. Sheryl Genco, and I'm the director of the Institute for Telecommunications Sciences, the nation's Spectrum and Comms Lab. On behalf of NTIA, I welcome all of you to ISART 2020. For returning ISART veterans and those who are new to ISART, those joining from different time zones around the world, and especially students who will become the next generation workforce and leaders for 5G and beyond. Welcome and thank you for joining us. Along with our 2020 co-sponsors, University of Colorado Boulder and the National Institute for Standards and Technology, NIST, we have put together an agenda and a roster of exceptional speakers, panelists, presenters to tackle the challenging and technical policy issues around securing spectrum for 5G and zero trust environments. Our collective goal is to leave ISART 2020 with new insight, hopefully some eureka moments and ideas for paths forward to solve some challenges and for securing 5G in a zero trust network. Maybe even some ways we can all work together. I'd like to quickly introduce myself, and then I'll provide some insight into our theme this year, run through the overview of the layout, the flow of this first ever fully virtual ISART, and explain some logistics. Then I'll introduce our distinguished leaders who will set the stage for the remainder of the symposium. So I came to ITS, Institute of Telecom Sciences, in May. Prior to that, I was with Honeywell Quantum Solutions. My PhD is in electrical engineering, and I specialize in microwave optics. So I've been around for a while, and I am very excited to be part of NTIA and working outward with all these excellent people throughout the government and the country. ITS realizes its goal is to realize the full potential of telecom into new eras of innovation. And these eras are just what I wanted to do when I applied for this job. So if any of you would like to contact me or talk more about my background, I'd be happy to do it. Focus of ISART 2020 is on 5G spectrum and a zero trust network. This was settled before I even joined ITS. It was sparked by the closing keynote address by Dr. Lisa Porter, whom you are honored to have on our morning panel tomorrow at the University of Colorado Silicon Flatirons Saving Our Spectrum conference last fall. At that conference, Dr. Porter said there's no such thing as a secure system. We can work to make things more secure, be mindful of vulnerabilities, but ultimately we must effectively use networks in which we have zero trust. This prompted ITS, whose researchers are all too familiar with spectrum interference issues, to look into what the new significant research and writings were around zero trust concepts and what they were saying about spectrum. Finding none at that time, the theme for ISART 2020 was born. The future wireless systems, 5G and beyond, are expected to offer major economic benefits to countries and companies that can deploy those networks and services reliably, quickly, and securely. Yet spectrum, the foundation for much of 5G, presents unique security challenges in addition to a multitude of technical, economic, regulatory, political challenges. While spectrum security historically focuses on jamming, spoofing, interference, a consensus developed that ISART was an appropriate vehicle to bring together those experts from government, industry, and academia to re-examine what spectrum security means in the context of zero trust environments, architectures, and networks. As ISART veterans will be shaking their heads, yep, while I bring up a little historical aside to explain why I think this symposium is so important. For others, I share this story to emphasize why your participation in ISART is so incredibly valuable and potentially transformational. About 10 years ago, nearly simultaneously with the 2010 presidential memorandum that directed NTIA to identify 500 megahertz of federal and commercial spectrum that could be repurposed for wireless broadband, ISART facilitated an open and well-engineered dialogue between government, industry, academia about the broad topic of spectrum sharing. An IRAC panel, for example, illuminated existing interagency spectrum sharing processes and set a basis for overall discussion. 2011, ISART focused on the unique challenges and opportunities related to spectrum sharing with radar services. A consensus was reached that spectrum sharing in the 3.5 gig band was a good potential for economic success. ITS followed up with ISART 2012 with occupancy measurements in 3.5 gigahertz near San Diego, which fueled an emergency policy discussion around citizens' broadband radio service. 10 years may seem like a long time, but to go from a theoretical analysis of potential feasibility of using the same spectrum band for high-powered DoD radars and a low-powered commercial wireless terrestrial service to initial commercial deployment of actual proven operational spectrum sharing is remarkable. I hope that ISART 2020 proves equally foundationally important for 5G and beyond wireless services. Our virtual ISART 2020 is structured in two-hour blocks each day. The organizing committee has worked very hard to find ways to incorporate tools for real-time interaction among our panelists and in-depth plenary talks, highly interactive Q&A, and opportunities for networking and conversation in breakout rooms. Right now, I'd like to thank our co-chairs, Andy Thiessen from ITS, Melissa Midzor from NIST, our Vice Chair, Rebecca Dorch from ITS, and a special thanks to an ITSer, Lily Segre. In addition, our technical advisory committee members from CU, Dale Hatfield, Pierre DeVries, and Keith Gremben, all of whom you'll see in various capacities and settings throughout the next 3.5 days. Thank you all. I'd like to encourage all of you to use the interactive tools, ask questions, converse with our panelists and presenters in the breakout rooms. We hope this will be very fun for all of us. This morning, many of you tuned into an excellent tutorial session that provided a baseline understanding for current engineering, technical, security, spectrum, and international aspects of 5G. The tutorial presentations were graciously recorded by the presenters, allowing any of you to return and check them into the baseline understanding later on. This afternoon, we officially kick off the formal ISART program and with a roundtable discussion between leaders of NTIA, NIST, and CU to help us set the stage. Then our keynote will be given by Dr. Joe Evans, who is spearheading DoD's efforts to operate in zero trust environments. Tuesday morning will feature our framing panel of experts with experience in government, industry, and academia, diving deep into what zero trust means with spectrum in the world and the known risks that exist today at the intersection of 5G, new radio, NR, and zero trust networks. Recognizing and naming the risks and vulnerabilities is crucial to identifying areas for research and developing solutions to better secure the spectrum that 5G serves. The technical core of this program is contained in the next 4 panels, which will examine 5G networks from the perspective of, first, ways to design 5G radio layer for resilient services. Second, how to implement secure and resilient technical solutions during deployment of new networks, including new network parts and features. Third, ensuring resiliency within a network set of operations, including handling spectrum interference. And fourth, how monitoring and data collection can and should provide valuable input and feedback into design, deployment, and operations to improve the resiliency of the network. The final closing and wrap-up panel on Thursday afternoon features polymaths to help draw new insights and connections, identify potential new research areas, and hopefully add to the history of ISART, triggering important out-of-the-box thinking and innovative ideas. I'm particularly looking forward to this week. The last half hour of each of the 2-hour blocks of ISART content is actually reserved for our breakout room. We hope the breakout rooms can begin to replicate the extent possible a virtual environment where we can have critical personal interactions with speakers and other participants that has always been a hallmark of ISART. After each panel concludes, the panelists and speakers from the sessions will exit the Blue Jeans events platform and head over to the Blue Jeans meetings platform for their breakout room. For those of you able to download and access our brand new ISART app, all the information and links needed to find in the breakout rooms are in the app. In addition, in the ISART confirmation email everyone should have received last Friday, there was a quick links that contains a 9-digit room number for the date and time each speaker and panelist will be in the breakout room. They'll be ready and available to chat with you at that time. Room hosts from ITS, NIST, and CU, who are our co-host organizations, will be there to help if needed. If you run into technical difficulties, reach out to the conference services staff listed in your confirmation email. The ISART app will allow you to reach out and connect with each other. By default, the only information anyone will see on the app is your name and affiliation. So if you're open and interested in chatting with others, networking, exchanging virtual business cards, please remember to go in the app and add whatever information you're comfortable sharing. You're also able to get a few 5G equipment suppliers and vendors to join us this week. So please virtually wander over to their rooms on the app tomorrow and check out the demo videos and ask questions. I'd like to just take one brief second to thank Conference Services as well. They've done a great job in preparing us for ISART. So thanks everyone out there. Now, without further ado, I'd like to briefly introduce our distinguished guests for the opening of Setting the Stage Roundtable discussion. Full bios for the speakers are in the program and in the app. I encourage you to check them out and read more about their wonderful accomplishments. Doug Kinkoph, my current manager and boss, has a very long official legal title, but for brevity, he is the acting assistant secretary and the head of NTIA, a position he has held since January of this year. He has been with NTIA for more than 10 years, and when not serving as the acting head of NTIA, heads up the NTIA's Office of Telecommunications and Applications that administers the administration's broadband programs. So you all know Walt. You're probably better. So Walt Copan is our NIST, the leader of NIST. He is director of NIST since I believe it was 2015, 2016. He served as the DOE's National Renewable Energies Lab Principal Licensing Executive and joins us today as our leader from NIST. Terri Fiez is the Vice Chancellor for Research for the University of Colorado Boulder, a position she's held since joining CU in 2015. After 15 years at Oregon State University and including as a head of their Department of Electrical and Computer Engineering. In her Vice Chancellor position at CU, Dr. Fiez leads the campus research enterprise and this summer has been working diligently on securing the campus for students to return. Well, with that, I want to thank everyone again, and I'll introduce Doug. And with that, Doug, you can take it away, and we'll talk to you later.
Thank you, Sheryl. Thank you. It's a pleasure to be with you today, and I welcome everyone who's tuning in. Sheryl, thank you for that great introduction on the role ISART has had in advancing thinking on spectrum solutions. This year, even in our virtual environment, ISART continues to provide a unique opportunity for people with diverse interests to share their perspectives in collaboration and collegial environment. I want to thank our ITS staff and our co-hosts in Boulder for their dedication to the success of this year's conference. I do want to take a moment to recognize Dr. Genco, Sheryl, who joined us this summer as ITS director and has really hit the ground running. And I'm not surprised, and anybody that knows her is not surprised, with such an impressive background from her work on quantum computing breakthroughs to her support on STEM education. She has really become a fierce advocate for ITS and its staff, and we're lucky to have her lead this extraordinary team. So thank you, Sheryl. We've been asked today to help set the stage for this year's theme on 5G spectrum and zero trust network. The conversations we'll be having today and throughout the week on 5G and security are really essential. From day one, the administration has recognized the importance of 5G wireless technologies to our economic and national security. We've also been clear-eyed about the risk and vulnerabilities posed to those who seek to exploit these technologies. NTIA has played a key role in a collective effort to ensure that the U.S. leads the world in secure 5G and beyond. That includes our work on botnets that began early on in the administration, our work to implement the national strategy to secure 5G, and our ongoing collaboration with federal agencies and the FCC to free up spectrum for commercial use. Over the years, our experience and expertise with spectrum clearing and sharing has taught us that a mix of techniques can free up spectrum while still protecting federal capabilities. While we will always look at clearing, a combination of some relocations and innovation, sharing methodologies can often be the fastest, most efficient way to accommodate federal and non-federal uses. Last month, we delivered a report to Congress summarizing our assessment of a key swath of mid-band spectrum, the 3100 to 3550 megahertz range. Our report concluded that the 3450 to 3550 subband is a good candidate for potential spectrum sharing, including at the commercial power level sought by the wireless industry. We are moving forward aggressively on the work needed to make this spectrum available as soon as feasible. 150 megahertz of spectrum just above that is a CBRS band, which represents a watershed moment in the development of dynamic spectrum sharing mechanisms. This year, we've seen licensed by rural commercial services launched throughout this band. The FCC is currently auctioning licenses for the CBRS service, and bids are now approaching $3 billion. It appears that the demand that we had thought was there for mid-band is active. CBRS is a culmination of nearly a decade of hard, collaborative work with our partners at the FCC, Department of Defense, and the private sector. And NTIA is proud of our contributions to the success of CBRS, including the work of its ITS Boulder shop, which conducted prototype testing of the key components of the innovative spectrum sharing technology. We are eager to see this technology achieve its full potential. Collectively across government, we're taking action so that we can meet the demand of spectrum, enable the promise of 5G and other technologies of the future to come to fruition. Achieving that promise is about more than just building out networks. It's equally important to ensure that 5G services can be safely and securely, that's a tough word there, accessed by American consumers and industry. In March, the President signed the Secure 5G and Beyond Act into law, and the administration published the National Strategy to Secure 5G. Strategy is focused on 4 lines of effort: facilitating the domestic rollout of 5G, assessing the cybersecurity risks to 5G capabilities and infrastructure, addressing risk to U.S. economic and national security, and 4th, promoting responsible global development and deployment of secure and reliable 5G infrastructure. This summer, NTIA sought public input to inform an implementation plan to secure 5G. We would like to thank everyone who took time to provide their views. The National Security Council, in close coordination with NTIA and a range of other departments and agencies, is leading the development of the plan, which will lay out specific activities to achieve the strategy's goals. In a separate track, last month, NTIA announced the establishment of the Communications Supply Chain Risk Information Partnership. This is a program required by law that is targeted towards small and rural equipment suppliers and providers of communication services. Our goal of the program is to improve their access to information about risk to key elements in their supply chain. We plan to build it out in phases and will be incorporating feedback from recent public comment to ensure that this important risk information is relevant and accessible. On behalf of our co-hosts, I once again want to welcome everyone to ISART. I'm excited about our program this year. On Wednesday, you'll hear from Sheryl, who recently joined NTIA to head up our international office. We're excited to have Jay join us. Even as we're limited in our ability to travel right now, our work continues with our international partners to achieve the U.S. interest in the future of a secure 5G and beyond environment. That's what we're all here to work towards. I'm so glad we're able to offer this forum to talk about how we can get it done. Thank you again to everyone for joining us today. And with that, Walt, I'll turn it over to you.
Excellent, Doug. Thank you so much. And I'm delighted to be part of this fireside chat session to kick off ISART 2020. The National Institute of Standards and Technology, NIST, has been a leader in developing innovative, groundbreaking research and development solutions, measurements, and standards for communication technologies for nearly 100 years. And we continue to do so today The mode of NIST operation is as a partner to industry and across government and the public sectors. The history of NIST goes back to 1901. NIST created the first radio that could run on AC current and pioneered a number of military applications, including the radio triangulation that was successfully used to locate ships and coordinate battery fire during World War I. NIST is known as America's innovation agency with wide-ranging collaborations around the globe, including with national metrology institutes and across the science, technology, and industrial communities. And just delighted to be part of ISART this year. NIST has a lead role in standards development on behalf of the US government and coordinating with other agency experts as well as with the private sector. In advanced communications for 5G and beyond, we're a leader in wireless R&D and in standards development, with over 30 NIST experts engaging in international standards development activities for communications. Just within our communications technology laboratory held in Boulder, Colorado, we've published over 320 research papers just in the past 5 years. Our experts lead in the all-of-government effort to secure the future of 5G and beyond wireless communications infrastructure for the United States. And we truly are partners across government and with the telecommunications sector in our standards development, and the sector looks to NIST for strategic guidance, such as the publication of the Future Generation Wireless Research and Development Gaps Report, which identifies several of the most significant needs facing the wireless industry today. NIST also led the IEEE 5G and Beyond Roadmap Working Group to identify hardware technology gaps for deploying millimeter wave fixed and mobile wireless, resulting in the IEEE 5G and Beyond Roadmap White Paper. Just last week, NIST announced that our communication technology lab engineers have developed a flexible, portable measurement system to support the design and repeatable testing of fifth generation wireless communications devices with unprecedented accuracy across a wide range of signal frequencies and scenarios. The system is called Samurai, which is short for Synthetic Aperture Measurements of Uncertainty and Angle of Incidence, which is the first to offer 5G wireless measurements with accuracy that can be traced to fundamental physical standards. The traceability is a key feature to assure accuracy of results. And it's small enough to be transported to field tests. So we're looking forward to this system being even more broadly deployed in active arrays in millimeter wave frequencies above 24 gigahertz with highly directional, actively changing antenna patterns. And of course, we know many of these are now utilizing artificial intelligence and machine learning protocols as the guide. NIST also relies on public-private partnerships in carrying out our programs. For example, the National Advanced Spectrum and Communications Test Network, NASTN, which is a multi-agency chartered partnership that includes DoD, NASA, NOAA, NSF, and of course NTIA, as well as academic partners and commercial carriers through the Coordinated Carrier Test Program, and CTIA, the Wireless Association. It's great to have a facility like NASTN, which leverages leading experts in radio frequency spectrum analysis across its partnership to understand the impacts of potential interference and also to evaluate spectrum sharing strategies for both federal and private sector users. And these analyses are neutral and informed by expert science to allow industry to build value using spectrum while maintaining important national missions. NASTN has issued a series of important reports in both 4G LTE, CBRS, and now beyond in the build-out of the 5G testbed. And NIST and NTIA are working hand in hand to implement the government's strategy to secure 5G, most notably in developing R&D priorities for 5G and beyond, and in developing a strategy for international engagement in communication standards, as Doug has mentioned. Also, the 5G millimeter wave Channel Model Alliance is a NIST-sponsored international research consortium to advance breakthrough measurement, calibration, and channel modeling approaches that are used for 5G and beyond. And of course, cybersecurity is a top priority for the United States. And NIST has a unique leadership series of roles in cybersecurity for the government and industry. Our cybersecurity framework has been adopted by many nations and organizations. And at the Cybersecurity Center of Excellence, the NCCOE, which is a federally funded research and development center, we partner with industry to provide practical example solutions to help address pressing cybersecurity challenges, in particular with 5G deployments. And we've been pleased to provide foundational guidelines, including our special publication 800-207 on zero trust architectures, which I know this conference will be discussing in detail. The zero trust architecture guideline is a series of model architectures and best practice guides, and it's intended to be a living document to continue to evolve as we look at deployment of security in zero trust applications for 5G and beyond. Another important area we're leaning forward on is strengthening supply chain security, clearly working with our government partners and also within industry and academia to develop guidance to ensure that supply chain for communications infrastructures will be secure from cyber or counterfeit threats, and that we can provide measurable guidance on how to maintain that security through manufacturing and distribution processes. And so there's a NIST program that is a planned approach for supply chain security that's intended to be less expensive to implement than provenance-based security strategies that can be implemented and independently verified at multiple levels across the supply chain through a rigorous testing protocol. Public safety communications research is another element of driving innovation using prize challenges with strong partnerships, including FirstNet and NTIA. Advanced cryptography is another key element of NIST's work, supporting secure communications and data protection, including post-quantum cryptographic algorithm and key distribution systems for the future. So in wrap up, NIST is committed to developing leading edge solutions from our unique vantage point, grounded in rigorous measurement science and standards, and engaging broadly in stakeholder partnerships. Thanks for being part of our conversation today. Let me turn it over to Terri Fiez from the University of Colorado, Boulder.
And I'd like to cover three things. The first I'd like to talk about is the research landscape, not only nationally, which you've already heard a part of that, but also looking at what we're doing at University of Colorado, followed by workforce development. I don't think we can have a conversation about what universities are doing without talking about workforce development and how we're helping to provide the workforce of the future. And finally, I'd like to talk about the whole continuum in the development of these technologies, from the basic sciences to engineering to commercialization. So let me start with the research landscape. In the United States, there were priorities established that really the focus is leadership in industries of the future. And those industries are, as you might expect, artificial intelligence, quantum information science and computing, advanced manufacturing, and of course, advanced communications networks and autonomy. And this is where the 5G strategy and the national spectrum R&D strategy falls into play. And from this, they're prioritized to develop R&D funding sources that will lower the barriers for spectrum, 5G, and also autonomous vehicles fitting all into that. The US government then, with a priority of 5G and spectrum, has put into place a number of different efforts already. The Department of Defense has a 5G program installing 5G test beds on military bases to hasten DoD adoption of 5G technology, enhance 5G, and invest in NextG. NSF, another funding agency, the National Science Foundation, in 2020 initiated two new spectrum programs. The first Spectrum and Wireless Innovation Enabled by Future Technologies, or SWIFT, a key aspect of this program solicitation is its focus on effective spectrum utilization and/or coexistence techniques, especially with passive uses, which have received less attention from researchers. The second program is the Spectrum Innovation Initiative, the National Center for Wireless Spectrum Research. The focus of a Spectrum Research SII Center, which is what these are called, may go beyond 5G, IoT, and other existing or forthcoming systems and technologies, and chart out a trajectory to ensure United States leadership in future wireless technologies, systems, and applications in science and engineering through the efficient use and sharing of radial spectrum. So now looking at with those programs and framing that, and looking at what we're doing at University of Colorado. And our efforts spanned a broad set of research that I'd like to just briefly highlight today, given our time constraints. So let me start with antenna technology. The CU Antenna Research Group, led by Dijon Filipovic, is making significant contributions towards frequency-independent, ultra-wideband antennas, antenna arrays, and simultaneous transmit and receive antennas. The Antenna Research Group works across the 5G electromagnetic spectrum from standard cellular frequencies up into millimeter wave. The RF Engineering Group, the Microwave and RF Research Group, which is led by Zoya Popovic, the Lockheed Martin Endowed Chair of RF Engineering. Her team focuses on microwave and millimeter wave circuits and antenna, but even reaches into terahertz frequency. Another area of research is ongoing work in high-efficiency power amplifiers for communications, among other applications. As we talk about the basics of the building blocks to create these kinds of 5G systems, University of Colorado has a really strong strength in position, navigation, and timing, or PNT. This connects to our aerospace department and the strengths that we have in aerospace. Our aerospace department is very renowned for the PNT work that's been done. For example, the Satellite Navigation and Sensing Laboratory, led by Jade Morton, deploys and maintains a global network of global navigation satellite systems, receivers, and RF sensors. The network provides continuous real-time monitoring and space weather and environmental propagation effects. So with our strengths in aerospace, I would be remiss to not also talk about part of the generation of this particular theme for ISART, and that's policy. The Silicon Flatiron Center at CU has a spectrum policy initiative led by Dale Hatfield and Pierre DeVries that seeks to inform and influence the national debate about events on spectrum security. This fall's spectrum conference will be an evidence-based spectrum policy. And finally, the last example I'd like to give from CU is wireless security. Since this year's ISART is about zero trust, I should mention the recent work by a team led by Dirk Grunwald, which demonstrated a practical spoofing attack on the President Alert System using commercially available hardware and open source software. Needless to say, after demonstrating the practicality of the attack, the team has been funded to develop defenses. So that gives an overview of what it is we're doing on the research side, just touching a few key things. Now I'd like to talk briefly about workforce development. That's a really important part of what we do as an education institution. Any of the research that we're doing or the courses that we teach engage students in really preparing them for the workforce, whether it's at a national lab, NTIA, or in industry, or starting something on their own. And so we have a significant amount of effort going on tied to the research that we're doing. There are several approaches that we're taking. We have outreach to local and national industry partners to determine the kind of training needed so that we really align it with what the needs are in the workforce. Second, we're developing more interdisciplinary programs to address system level challenges. It's easy to be in the component levels, siloed areas that we work in, but it's really systems that are going to solve the problems of the future. And third, we're committed to inclusiveness and diversity, as demonstrated by our BOLD Center, which is broadening opportunities through leadership and diversity, which focuses on bringing underrepresented populations into industry. Finally, I'd like to talk a little bit about support for fundamental sciences to engineering to commercialization. It isn't enough just to study technologies. We need to also engineer them and pursue pathways to commercialization, and then accelerate the incubation of these technologies. We need to partner nationally, internationally, and regionally, and think about how do we raise all of the boats up. As a major research university, we can help facilitate bringing together all of the parties to create a playground that is neutral. And that's the role that at University of Colorado Boulder, we really work to partner with our industry partners, with our national lab partners, and really help to accelerate these new technologies as they're developed. Our goal is to foster economic development through our role as an enabler. So with that, I want to thank all of you for being here, and I'll turn it back over to Sheryl.
Thank you, Terri. You make me feel like I almost want to go back to school. So very exciting stuff over there at CU. We only have about 5 minutes. We had some questions for our roundtable participants. Maybe what we could do is try to shorten up your responses, and let's try the first question. Why is your organization important to 5G, Doug? Why don't you take that first? We'll go in the same order as.
Sure, that's fine. Thanks, Sheryl. You know, as the principal advisor to the President and Administration on telecom and technology issues, NTIA plays a number of key roles. We work often in collaboration with our partners across federal government and with other stakeholders, including state and local governments. And of course, as a bureau in the Department of Commerce, NTIA is keenly focused on advancing U.S. economic activity, global competitiveness, and 5G will drive growth across many sectors, create jobs, and improve lives for the Americans. But NTIA spectrum management responsibilities are critical to 5G and beyond. And obviously, our spectrum powers 5G communications. The airwaves are heavily congested, and we need to find a way to use spectrum as efficiently and effectively as possible so that we have it available for 5G and other critical uses. And, our ITS research mission is, to advance telecom, inform our stakeholders, and investigate challenges. When our unique experience that they have in RF and radar is combined with 5G and beyond technologies, ITS has a unique capability for our country. So I think NTIA, just from a spectrum and ITS Boulder Lab standpoint, and then you throw that onto our expertise in like Broadband USA, where we actually work directly with communities on advancing networks, which will help with the 5G networks throughout rural America, and our work on in the federal government side on helping lead the American Broadband Initiative with the White House. I think we're well positioned to play an important role in advancing 5G for the American public. Back to you, Sheryl.
Thank you. Walt, why don't you take the same question?
Sure. Similarly, the role of the NIST director is to serve as a principal advisor to the president on standards and technology matters. And so on issues related to 5G and spectrum utilization, we are a partner to NTIA and to the other elements of the federal government, pushing the boundaries of measurement science to make new spectrum accessible and ensuring a science-based approach to 5G standards. NIST also has leadership in the development of trustworthy AI and machine learning, which has led through breakthroughs in spectrum sharing strategies for 5G, and that links to the standardization efforts that NIST leads for the nation in trustworthy artificial intelligence. Lastly, I would say that the collaboration on large-scale research programs such as the role of NIST that I mentioned previously, allows collaborations to go forward on an accelerated timetable and whose research outputs informs policy decisions. And so it's an important part of the national infrastructure with regard to effective standards for the future.
Thank you, Walt. Terri, would you like to add anything? We have a few more minutes.
Yeah, I'll just make a couple quick comments. You know, when I think of the university, I think of it as being the ultimate playground. We can try out ideas and we can actually fail. And the best way to be innovative is have an opportunity to be able to try things that aren't going to work. And that's where you get solutions for the future. So I see the university doing that on the technical side as well as on the policy side, and really helping to inform our partners, NTIA, NIST, and industry and other national labs. And then, of course, I already mentioned the workforce. You know, we've got to continue to think about the workforce of the future. They've got a different skill set than many of our more senior workforce. They can work on AI, machine learning. They have computing skills that are advanced. They have a different way of working. They're used to working in a different kind of environment, like all of us have moved to now, being online. So, you know, it's an exciting time, and I think all of us being able to partner to address this is really how we're going to move forward.
Thank you, Terri. I agree. Collaborations and technical achievements have to go hand in hand. We have exactly 3 minutes, so why don't you each take 1 minute and try to help us understand what you feel are your most impactful objective or the role of your organization, the most impactful role of your organization, and why. Doug?
Okay, so it's like asking me which of my children is my favorite. Let me, but boiling it down, it's hard not to stop at the critical role of NTIA spectrum management responsibilities and the team there. And that, of course, is supported by research at ITS and the advancement of communications, electromagnetics, propagation modeling, and RF, et cetera. It goes on and on. But, you know, we're entrusted to do manage the federal government's use of the spectrum. And it's the one thing we do that's closest probably being a regulator, during managing the radio spectrum with the FCC, which manages the non-federal use. I think it's difficult for people to really appreciate how diverse federal government uses of spectrum are, and ensuring that we have the most capable military in the world to space exploration, weather forecasting, controlling the nation's airspace, while also leading the world in 5G in the industry side. So I think that is a huge load for that NTI carries, and one we take great pride in taking on. So that, keep this short. I'll just turn it back over to you, but that's the spectrum management role.
Thank you, Doug. Thank you. Walt, how about you?
Yeah, very briefly, people know NIST for its wide portfolio of science and technology development that touches upon all market sectors, all industries, and ranges from foundational research in our labs to manufacturing deployment, and is known as industry's national lab as a trusted partner globally, together with a strong focus in cybersecurity. So it's that broad interdisciplinary focus from the laboratory to the marketplace that characterizes NIST and our role for the future.
Thank you. Terri?
Yeah, really quickly, I think one of the things in terms of the impactful objective is identifying and filling the gaps of shortages. So as we talk about RF engineering, for example, there are major shortages in the workforce. And through the research, we really can partner with, again, the industry and our federal labs to fill the gaps, to basically make sure that we have the workforce that we need in these areas that are very difficult to hire in. And then finally, a major part of what we do is become a convener and also an entity that can look far out into the future to help create the vision of what the future could look like.
Thank you, Terri, and I agree. RF engineering is very difficult to find folks who are in that field, and I'm very proud of what you're doing over at CU. Thank you. Well, with that, I think this session has come to a close, and I would like to introduce Dr. Joe Evans. We enjoy working closely with Dr. Evans and his team on DoD's 5G deployments that are captivating the attention of industry as DoD embarks on a number of important 5G projects throughout the United States. So with that, I'm going to ask Akeem if Dr. Evans is ready.
Can you hear me?
Now I can.
Great.
Nice to see you again, Joe. Take it away.
Thanks. And I can see the slides. That's great. Hope everyone can see those. And so I'm Joe Evans. I'm the Principal Director for 5G with the Department of Defense. We are currently engaging in a number of activities across the Department of Defense and working with our government partners, as Sheryl said. And so I hope through this presentation to convey what we're doing, and specifically a few things on the topics of the ISART 2020 program, 5G spectrum, and zero trust. So let's go to slide 2. And that will provide a little bit of context. So why do we care? Well, we care about 5G because it's transformational, and not just new radios and faster cell phones and kind of a slightly better 4G. It's really designed to be ubiquitous connectivity, the fabric to connect not just human to human, but machine to machine and human to machine. And so it's this connectivity fabric that really makes 5G exciting in terms of what it's going to offer in terms of services, but also in terms of how it changes the network architecture and how you have to think about the network. And so one of the that's some of the good things about 5G. On the other hand, we also have to acknowledge that there's no such thing as a secure system. So we have to operate on networks in which we have zero or little trust, and be able to operate through adversary impairments, impediments to our ability to use those networks. And because 5G is such a re-architecting of the network, it presents a lot of attack surface that just didn't exist in previous instantiations of cellular technology. So we have to focus on those types of things, kind of the zero trust philosophy, as well as all the good things that we can get for DoD by using that technology. One of the key things that we're doing is partnering with industry to understand and influence 5G. That has to be the fundamental aspect of our approach, because industry is driving 5G. DoD is a relatively minor player in an industry that's going to be, spending $350 billion on capital expenditures alone to deploy 5G in the United States. So that's a massive investment, and DoD, just doesn't do things at that scale in networking and communications. One of the other numbers I like to cite is Samsung, one company. In 2018, 1 year, their R&D budget alone as $16.7 billion. There's never been a DoD networking and communications program of that scale. We are, a minor player in this industry, and we are getting dragged along in terms of networking and communications capabilities by the commercial world. Our users, the soldiers, airmen, Marines, sailors, they're all expecting to be able to use capabilities like you get with 5G, and so DoD needs to enable those capabilities, but it needs to enable it by building upon the massive investments that the commercial world is making. And this is critically important for the military. So if we go to slide 3, this gives a little bit of an overview of the overall DoD 5G strategy. And I'll focus in on a couple of these items in the remainder of the talk, really mostly the top 2 here. But I wanted to give a sense of all of the things that are going on throughout DoD in terms of technology development, security and operating through vulnerabilities, standards and policies, as well as partner engagements. And it's, like I say, a pretty broad-based strategy with many participants throughout the department. So in terms of technology developments, probably the thing that's been most obvious to the outside world has been hosting 5G demonstrations, prototyping, experimentation on networks and applications, enhancements. But we've also been looking at RF technology, spectrum sharing, open architectures. All of those are wrapped together into some of our prototyping and experimentation activities. And in the future, we plan to work on workforce development as well, because we need to make sure that DoD has the right folks to be able to utilize this technology, and the right type of folks that can also work on U.S. military bases and so forth. In terms of assessing, mitigating, and operating through vulnerabilities, we're certainly working with our partners throughout the U.S. government, throughout both DoD and the intelligence community, on looking at threats and how to minimize those threats, and then also how to use 5G globally despite adversary capabilities. So we believe this cybersecurity, zero trust piece of the program is very, very important. We've also been working across the interagency and throughout DoD on standards. We have partnered certainly with our colleagues at NTIA on this, and DoD CIO within the Office of Secretary of Defense. DoD CIO is really our lead organization on standards. We're working closely with them to work across the interagency. DoD CIO is also very involved in advanced spectrum management. We believe that we need to modernize policies to be more dynamic as we develop those, further develop those technologies as part of this program. In terms of engaging with partners, obviously congressional engagement, that sort of thing, but we think it's also important to engage with our international allies and partners on everything from supply chain and assessments, as well as we're starting to look at how we work with allies and partners on particular experiments. And just to wrap this up, industry engagement, as I mentioned before, is kind of a fundamental aspect of this program. And we're working with industry through several mechanisms, both, a couple of consortia in particular, both the National Spectrum Consortium, the NSC, as well as IWRP, the Information Warfare Research Program. We think that they can provide kind of complementary consortia capabilities, and also a wider variety of contracting options to work with our industry partners. The next slide, slide 4, starts to slide 4, please. Next slide, slide 4, talks about a little bit about the 5G prototyping and experimentation aspect of the program. So this is kind of taking the first couple of areas on that previous slide and drilling down a little further into those. And I'm going to wrap even further down into those as we move forward here. So in terms of, sorry, go back one to slide 4. We have 3 thrust areas as part of the overall program. The first is what we call Accelerate, which is hastening DoD's use of 5G technologies, and that's what you see throughout the initial throughout the initial release of solicitations. The second area called Operate Through is focusing on ensuring that we can operate wherever and whenever we deploy, because DoD does go quite a few places around the world. And this is a mix of dynamic spectrum utilization, dynamic spectrum sharing, as well as this idea of zero trust to be able to operate over networks in which we don't necessarily have a tremendous amount of trust. And then this also includes perhaps DoD specific enhancements to commercial technology to fill gaps where we need to. The last area is innovate, and that is enhancing 5G technology and investing in future 6G, 7G, and so forth technologies, because this will be a continual race. There's no finish line here. In terms of the scale of these programs and current activities, the first two areas there, accelerate and operate through, are 6.4 research in DoD parlance, so pretty high TRL, advanced development and prototyping, and those are meant to be those areas are meant to be providing prototypes that can then be used in actual DoD systems at the end. The scale of that effort is on the order of about, in the President's FY21 budget, that's on the order of about $449 million for FY21. The last area, innovate, is essentially 6.2 research, so that we can reach out to a wider range of folks at a more basic research level, universities, for example. That is about $35 million in the FY21 budget request. So that gives you a sense of scale of those activities. In terms of, if you go back one slide to slide 4 again, the first area, accelerate, that is being executed through the Tranche 1, 1.5, and Tranche 2 experiments. And those solicitations are on the street. Operate through, we are anticipating solicitations in that area. Some of those will be unclassified, some perhaps classified. Those will be in early FY21. And the innovate area will also be solicitations in early FY21. So next slide now, to slide 5, talks specifically about some of the ongoing solicitations and where they are and the experiments that we're just standing up. So Tranche 1 consists of 4 sites with essentially 3 to 4 types of experiments. Hill Air Force Base is focusing on dynamic spectrum sharing. Joint Base Lewis McChord, that's focusing on augmented reality, virtual reality for distributed ground combat training, scaling up to larger unit sizes up to grade level. And then Naval Base San Diego and Marine Corps Logistics Base Albany are focusing on smart warehousing. At Naval Base San Diego, it's really transshipment, putting things in pallets to ship to ships at sea. And then at Albany, really focusing on vehicular maintenance and warehousing, things like MRAPs and trucks, being warehoused. So those are a couple of a few of the initial Tranche 1 experiments. Those experiments are in the middle of source selection, and we're hoping for announcements of the awards on that within kind of the next few weeks, we hope. In Tranche 1.5, kind of an intermediate step, we're working with the folks at Nellis Air Force Base on a distributed combined air operations center concept, basically distributing command and control functions that normally would sit in a big building, distributing those in multiple locations to make them more survivable. We're also hoping to be able to announce the awardees there probably in the next month to 6 weeks. Next slide, slide 6, talks about some of the specific, slide 6. Next slide. Okay. We get there? No, there we go. Okay. Slide 6 talks about one of the specific experiments, and this is the AR/VR work at Joint Base Lewis McChord in Washington. And this is using virtual reality type or augmented reality types of headsets in order to perform distributed ground combat training, and actually in the end actually support operations in the field as well, using that AR capability, AR overlays in those goggles. The experiment is being performed at both JBLM as well as the Yakima Training Center, which is out in more central Washington across the mountains, where you can do larger scale maneuvers, again, because we want to reach this goal of brigade size deployments. So the next slide dives into the warehouse activities at Naval Base San Diego, so slide 7. And that's at Naval Base San Diego, really focusing on that kind of, I think they call it retail warehousing, small pallets being collected for transshipment to other locations. And so we're focusing on that at Naval Base San Diego, setting up a warehouse in order to start looking at integration with Navy logistics systems and automation of those types of warehouse functions. The next slide, slide 8, talks a little bit about the Marine Corps Logistics Base Albany smart warehouse, which again is focused more on vehicular warehousing, large vehicles and large warehouses where there's also a maintenance aspect associated with the warehouse, because you have to test, keep track of the health of those vehicles, oil leaks, and all those sorts of things that come with maintenance of large combat and logistics types of vehicles. The next slide, slide 9, talks about the work at Hill Air Force Base, and we consider that one of our most interesting experiments because it is really focused on understanding how radar systems and 5G can work together, particularly in the mid-band spectrum that is of incredible interest right now throughout the nation, in order to make 5G deployments more widespread and more economical. And so we are focusing on basically testing, evaluating the impact of 5G on the airborne radar, as well as the impact of the radar on the 5G system. And so we're building and deploying mobile infrastructure at Hill Air Force Base, as well as the Utah Test and Training Range. So using cells on wheels, or as they're called now, cells on light trucks, PULTs, to implement the 5G, to deploy the 5G network, so that we can then instrument it and understand what is happening in the interaction between these different waveforms in those particular bands. So you can see, just to briefly recap Tranche 1, you can see that obviously the dynamic spectrum access has direct commercial interest in being able to use that spectrum. But the other thing we'd like to emphasize is that the other experiments have a dual use aspect, and so we're also providing an opportunity for industry to come and use these bases as a place to experiment. Relatively low risk. DoD in this case is a friendly customer and will help with permitting and access to the bases. So offer an opportunity to do some dual use experimentation. In other words, in the smart warehouse case, there are direct analogs in the commercial world for smart warehouses, and there's a direct analog for AR/VR, obviously gaming and things like that, as well as support of maintenance and so forth. There are direct analogs between the DoD use cases, those applications at the high end of the value chain, and what is being explored in industry. This is an opportunity for industry to experiment in a friendly environment, and hopefully move this technology forward for both the benefit of DoD and our U.S. industries. The next slide, slide 10, talks a little bit about the Nellis Air Force Base experiment, and really focuses in on a very warfighter-oriented project. And in this case, it's distributing command and control functions throughout an operating area in order to reduce susceptibility to targeting and attack. And so disaggregating those command and control functions to multiple locations. So, as with many of our different test beds and experiments, it really has three parts. One is build the localized 5G network that can be distributed, develop the command and control capabilities, and then do network enhancements to kind of fill the gaps to support the military operations and as needed. Slide 11 dives a little bit deeper into the Nellis Air Force Base activity and talks a little bit about the phases and give you a sense of where we're going with this. And so in phase one, it's really pull the Combined Air Operations Center pieces apart and be able to put them in multiple locations interconnected with a 5G network. The second part is, well, can you then speed up the cycle so that you can make these functions nomadic and move those functions around in trucks or whatever? And then in phase three, can you make it actually, truly mobile, so you can perform these functions on the move, make it very difficult to target the command and control capability. So that's where we're going with the Nellis experiment. Like I say, very warfighter focused activity in that particular case. Slide 12 then talks a bit more about what we're doing in terms of the next tranche of bases that we've announced, tranche 2. So that's slide 12, I believe. And in this particular case, we've named 7 different locations for this experiment, for the moderator, slide 12. And the tranche 2 is really pretty broad-based set of experiments and locations. And so at one of these locations, we're doing essentially ship-wide and pier-side connectivity. That's with the Navy at Naval Station Norfolk. The idea there is communications within a vessel using 5G technologies. Can you reduce holes in bulkheads and provide better connectivity for sensors moving around the ship and personnel moving around the ship? And also, can you provide connectivity from the ship to the pier side as you arrive? And you can think of dual uses here as well in the logistics industry, where you may be monitoring containers on a cargo ship, or at the pier side, a cruise ship arrives and you want to be able to quickly download information from all those passengers to the pier side. So you can think of dual uses for many of these applications. Enhancing mission aircraft readiness, that's at Joint Base Pearl Harbor Hickam, with all the services, most likely including Marine Corps Base Hawaii across the mountains with that. And that's really looking at how you download data from the aircraft when they land, upload information for missions, and do maintenance. One of the things that we discovered with commercial partners, Boeing, Airbus, and so forth, is that they have similar types of problems. They want to do predictive maintenance, collect data when an aircraft lands, pull the data off, and understand if there are any issues before that aircraft turns around in 30 minutes at the gate and leaves. And so we need that high bandwidth capability in order to quickly get that data on and off the aircraft, as well as support high levels of maintenance where you might want to have some sort of augmented reality display showing schematics or so forth, or the ability to reach back, which is also the topic of the next experiment, which is AR support for medical training and telemedicine. And this is at Joint Base San Diego with both the Army and the Air Force. And this is looking at both medical training, sort of the see one, do one, teach one type of thing, but with augmented reality support so that multiple individuals can get a kind of surgeon's eye view of what's happening, as well as the ability to reach back with telemedicine, so that say a medic in the field can reach back to a doctor or specialist in order to provide better care at the kind of tactical edge. The next experiment is wireless connectivity for tactical operations centers and combat operations centers, using the different terms for the Army and Marine Corps. And the Army will be doing this at National Training Center at Fort Irwin in California, as well as the unit being trained will come from Fort Hood, Texas. The Marine Corps will do this at Camp Pendleton. And really what this is we're replacing all the wires that run around a tactical operations center, seeing how much of that you can make wireless, but at multiple security levels. The next experiment is a pretty exciting one that really spans the nation. This involves Joint Base San Antonio as kind of the hub or center of gravity of the experiment, but also multiple remote locations, basically all of the sites that we're looking at. And this is kind of under the auspices of the Air Force, but really will involve all the services in the end. And it's really looking at 5G core. How secure can we make it? So doing security evaluations, but just as importantly, understanding interoperability between 5G core instantiations, different implementations from different vendors. We are working with partners at DARPA as well as NIWPAC on this particular experiment. The last Tranche 2 experiment that I'll mention is bidirectional spectrum sharing, and that's basically the ability to share spectrum between DoD applications, either DoD 5G or DoD some other waveform, and commercial 5G. And really more of an emphasis here on communications maybe than at Hill Air Force Base, where we're doing the high power radars. But a variety of waveforms at Tinker as well. This is with the Air Force and focusing really on emergency national security types of instances, trying to do bidirectional spectrum sharing where both entities are co-primary in a band, and how you might share that spectrum, rather than kind of the model that we've used for CBRS and some of these other bands where there's clear primary and a clear secondary. Can we get to kind of a co-primary type of relationship, and really primarily to be exercised in of national security? So kind of to change topics a little bit, why don't we go to slide 13, which talks a little bit about our operate through activities. And so what this is doing is trying to lay out a way to think about DoD's security needs as we move forward. And so many DoD use cases have security requirements similar to commercial use cases. And so if you look at this graph, that lower left-hand corner kind of is where commercial systems live, and they obviously have quite stringent security needs, but maybe they don't have nation-state adversaries to deal with all the time as kind of the bread and butter. And so DoD needs to be protected against more sophisticated national security threats, and also needs to ensure resilient operations in multiple threat environments. So that's what this graph is trying to capture, is that we believe that DoD can use commercial systems throughout a range of situations, different threat environments, and also different threat sophistication. It won't answer all of our questions in terms of, or all of our needs in terms of what DoD must have in order to operate, everywhere, every time. But we believe that we can cover down a significant part of this space through our investigations as part of the operate through activities. And so our kind of direction forward on that, and kind of the as highlighted by the topic of this event, is that we really think zero trust is very important, and not just kind of zero trust research is what we're looking for. We're really looking for how we create the zero trust applications, frameworks, systems in order to start deploying those and use those for secure operations in many of these different environments with different levels of threat sophistication. We believe that we need to get away from perimeter defenses and really move towards the zero trust aspects where we have layered security with different authentication, authorization down to the finest grain, encryption, so forth, really embedded throughout the protocol stack from the ground up, and again, not believe that we can build a perimeter and everything will be okay within. So that is one of the key messages we'd like to get across, is that we want to not just research that, do that in a little way. We want to move towards how we create the DoD applicable infrastructure as well as applications that use the zero trust philosophy. We don't think that that's just the cyber side, by the way. We also believe that we need to carefully understand what our spectrum needs will be and how we will work in spectrum in unfriendly environments as well as in friendly environments. So the next slide talks a little bit about some of the expected outcomes from the program, and I won't go through all of these, but I just want to give you a sense of where we think we're going and where we the results we hope to get. So we hope to be able to certainly hasten DoD's use of 5G by coming up with expedited authorizations to operate, bills of materials, basically make it easier to deploy more quickly and at lower cost on U.S. military sites. Make DoD operations more efficient by networked autonomy, things like that. And then finally, improve DoD operations, rapid deployment, use of 5G systems, both use of the systems as well as use of the piece parts. We believe multi-antenna systems, things like that may be useful as well. So we need to explore the range of possibilities there. In terms of operate through, well, counter-adversary attempts to deny access to the spectrum as well as networks so that we can do this, have this ability to go anywhere, anytime, and use 5G. And then finally, innovate, start to produce those or help produce those next G technologies that will make us competitive as a nation in 6G, 7G, and beyond. So the last slide just is kind of a summary slide that this is very important for DoD. It's a major initiative within DoD that spans the entire department. We are working with our partners within DoD as well as throughout the interagency to both use 5G as well as to help secure the 5G ecosystem. We also acknowledge that we need to be doing this for 5G, but we also need to make sure that 6G, 7G, and beyond are on our roadmap as well. And it is a fundamental technology that DoD needs to leverage and work with 5G, the U.S. 5G industry, to make sure that the U.S. is competitive and able to use these technologies into the future. And with that, I will turn it over for questions. Thanks.
Thanks, Joe. We have a couple questions here. So the first one is, Dr. Evans, how scalable do you think the sharing solution between 5G and radar will be? For example, will it scale to include DoD comm systems? Or do you envision different sharing techniques between 5G and other systems, depending on the coexistence scenario?
That's a really interesting question, and in part it's answered by our additional work that we're going to be doing at Tinker Air Force Base, because that's really more focused on communication spectrum. sharing. I view the radar spectrum sharing problem to be, one of the hardest for spectrum sharing because of the vast power differences, first of all, between the systems. Many of the systems DoD uses in terms of radars in these bands are pretty darn high powered, but also in terms of the sensitivity of the radars to interference, essentially. And so we certainly need to work on that problem in general for radars, but we're hoping that the communications problem might be, I won't say a little simpler, but at least the physics of it won't be quite so daunting.
Very good. I have another question. Does it cause you any concern that the DoD and the commercial sector are putting so many of their communication eggs in one 5G basket? What are the drawbacks of depending so much on a single standard or technology?
That's a very fair question, and I think the DoD approaches most comms systems with an acronym by the name PACE, the primary, alternate, contingency, and emergency, and so rarely is there one single solution that is viewed as the be all end all for DoD. One of the things I'm trying to convey with that graph of threat sophistication and threat environment is that we really think that there's a range there, and we need to architect the network solutions, 5G or otherwise, to fit the cases in which we operate. And so if we're talking about 5G operations or operations in the U.S., 5G may be completely applicable to a smart warehouse, something like that. It may also be, applicable to a smart warehouse in a deployed location, depending on what the adversary. And so, if you, went back to our deployments in Iraq or Afghanistan, there's a pretty wide use of essentially commercial technologies at various levels within that environment, and not necessarily for cellular, but for other types of communications and so forth. And so, not everything has to be, the best tactical radio that you can ever build, because DoD doesn't operate in, a high threat tactical environment all the time, everywhere. A lot of our operations are fairly boring, and in a base in the U.S. or in a allied country, and we don't need, and it's not cost effective for the U.S. taxpayer to pay for, the most extreme systems that are needed in emergency situations for every single communications need. We need to architect appropriately to the threat environment.
Very good. Let's see here. Are there any roadmaps or specific requirements for the zero trust for 5G and beyond for DoD and government agencies or for the industry to adopt?
We have not developed what I would call a roadmap for zero trust yet. We are in the process of working with our partners within, DoD CIO in particular, but also as part of the 5G initiative in, putting together some plans for that. We, as I mentioned earlier, will be standing up the operate through area in early 2021. We'll be bringing on a leader in that area to start putting together solicitations for release, focusing on operate through, and that will include zero trust architectural work. What we hope to do is to prototype systems based on that type of architecture that we can then move towards wider deployment within DoD. I would expect to see a roadmap for that as we move forward in the next year or so, but that's still a work in progress, to be fair.
That is very fair. In leveraging RF technology, where is the United States millimeter wave expertise and technology best applied to meet the goals of the DoD 5G office? Thank you.
Thanks. That's really another good question. So we're very excited about the use of millimeter wave. The U.S. has some pretty significant advantages in that area. We've worked millimeter wave systems for many years, both at kind of the lower end, low power, but also high power, mobile airborne systems. I mean, we really have quite a bit of expertise in that area. We think that some of it may be for kind of traditional uses like backhaul and that type of capability. But we're also excited about the idea of using it in places where we don't want such an obvious RF signature. And so we think that the lack of good propagation of millimeter wave at lower powers is actually an advantage in many DoD scenarios. So we would like to be able to use it in order to provide high bandwidth services, but not be radiating quite so obviously, and thereby become a target. So we are definitely interested in that kind of different view of the use of 5G. Or millimeter wave in 5G. We do think that there are some early examples that we've seen from industry, U.S. industry, of exciting millimeter wave beamforming capabilities, things like that fit wonderfully with our needs, and so we hope to see that as part of several of our early tranches of projects.
Excellent. At this time, does the DoD envisage working with the allies on 5G? That's Pierre DeVries, everyone.
Yes, Pierre. Yeah, we certainly do. I think both the DoD 5G strategy as well as the national strategy to secure 5G both call out an interest in working closely with our allies and partner nations. And yes, we certainly anticipate doing that. We are again just in the process of putting some of that together. But I think probably over the next half year we'll be kicking off some opportunities there. We certainly had early conversations, and we see tremendous value from that sort of interaction.
The DoD announced the 3450, 3550 spectrum would be redeployed to commercial use. What use conditions do you see for this transition, and do you know the time frames? Off
the top of my head, I don't actually know the time frames. I haven't kept up with the latest auction announcements and so forth. But we see a trend where we have to do increased spectrum sharing in general, not just in that band, but in other bands. And what we're trying to do with our 5G initiatives is in spectrum sharing is exercise some of those use cases so that we can offer technology solutions to the policymakers, so that there are different ways we can move forward to start sharing more of that spectrum. And we think that benefits not just U.S. industry, just flat out in use of the spectrum, but we think that it benefits DoD in terms of being more agile in general. But also maybe even offers an opportunity for U.S. Allies and partners and U.S. Domestic industries to develop and deploy technologies that are, leading edge and useful around the world. So that's really part of the reason for our emphasis on this dynamic spectrum sharing in several of the test beds.
Very good. Can you talk a bit about spectrum deconflicting, such as on ships and aircraft, and other anti-self-jamming needs within the DoD, and where this is happening?
Yes, we need that. So certainly those are hard problems. And I'm not sure I have a general solution or a general comment on that, other than as part of some of our individual projects, we'll be looking at those problems. So certainly, some of the things like the Hill Air Force Base, looking at airborne platforms and so forth. But, obviously with the shipwide and pierside connectivity projects with the Navy, very, very tough electromagnetic environment in those cases. One of the things that we're hoping is that with the use of some of these other bands, millimeter wave bands and so forth, we might be able to make some progress by essentially going where there aren't a lot of systems already. That's a hypothesis. We'll see what we can do in the awful environment of a metallic ship, but that's what we're looking forward to.
Very good. I don't seem to have another question for you, Joe. So I want to thank you from NTIA and ITS and look forward to meeting you someday in person. And I think now, if everyone wanted to go to their breakout rooms, some of the speakers will be available. I believe that Doug Kinkoph got called away. He may be in his breakout room a little bit later on. So again, Joe, thank you for your time and support of ISART. And with our co-hosts, we want to extend you invitation to speak to us again sometime.
Great. Thank you very much. Really appreciate it. Thank you.
All right. So long.